We are having this question, example 2.15 from an NCERT book. Here it is given that we are given this equation, half mv square is equal to mgh. So check that this equation is dimensionally correct or not. What now? Let us solve it on board. So you are given this expression, that half mv square is equal to h, and you are being asked that check that this equation is dimensionally correct or not. Yes, students, you all know that this is the formula of kinetic energy on the left hand side, and it is the formula of potential energy on the right hand side. Since both are energies, so then both must be equal. Let us look for it. Taking the left hand side. If we take the left hand side, you see that it is half square, which is, you all know that m is this capital M, and this v square is LT minus 1, just found out, square. So this is equal to ml2 t minus 2. And since you all know that dimensional analysis does not speaks about any constant such as pi, epsilon naught, mu naught, or any number, that as we can see here, that half is there. Half it is not telling about. See, we cannot talk about any such constants. This is the drawback of the dimensional analysis. And you can see in the right hand side, if you take the RHS, right hand side, let us go for here also. MGH is here. We are having MGH. This M is again M, and you are knowing this G. G is what? Again, it's a acceleration due to gravity, which can be written as LT minus 2, and this H is again the distance or length, which is the L. So you can see you got ml2 t minus 2. So both the LHS and the RHS are equal. So this equation is consistent. We call the term consistent. This term is consistent. This analysis is consistent with each other. Okay, ml2 t minus 2. Now you see, you have next problem. The SI unit of energy is shown. We have to find which formula is correct. So dear students, I would suggest you to do this problem by your own. I would like to solve one more problem, example 2.17. See what is there in this example. You are given a question is that consider a simple pendulum having a bob attached to a string which oscillates under the action of force of gravity. Suppose that the period of oscillation of the simple pendulum is L, mass is m, and acceleration is g. So derive an expression for the time period using the method of dimension. We have derived the time period for simple pendulum using the methods of dimension. See, dear students, in this we are being asked to derive the time period. So let us assume that time period is shown as capital T, and this time period is given that it is found that it is proportional to the length. So suppose it is A times proportional, we can assume that it is proportional to mass Y times it is proportional to mass B time, and thirdly it is proportional to your acceleration due to gravity C times. This is our assumption. When you are given to derive any equation, you have to adopt similar methods. So what we can write at the end? We can conclude that this time period is proportional to L to the power A, N to the power B, and G to the power C. Or we can write that this time period is equal to, say, some proportionality constant is here, L to the power A, N to the power B, and G to the power C. We will simply use the methods of dimension to get the value. See what we will do? We will equate both sides. How? Let us do. See, on the left hand side, this left hand side could be very easily written as n to the power 0, L to the power 0, and t to the power 1. And now in the right hand side, k is here, no issues, it's a constant, and we are all knowing that constant has nothing to do with the dimensions. Now length is L to the power A, mass is N to the power B, and lastly remain is your acceleration due to gravity, which is nothing but L to the power minus 2, and here power C is here. Now what we do? We will collect the like terms together and solve for the and equate from the both sides. See how it can be done? Is equal to k. You can see this is here N to the power B. Again you can see L to the power A plus C, and lastly we are having T to the power minus 2 C, and on the left hand side we are having, as we have seen, M0, L0, and T power minus 1. Comparing the coefficients, since you all know that if base is same, the power can be compared, coefficients can be compared. You can see that then this B is equal to 0, equation number 1. If you compare for we will do in the slight way, that if you compare for length, then A plus C is again equal to 0, and lastly if you compare for time, then minus 2C, see here, minus 2C is equal to minus 1. So this minus will get cancelled from both the sides, and you will get that C is equal to 1 by 2. Therefore what you get? Suppose this is equation 1, equation 2, and equation 3. So from 2 what you get? From 2 you get that A is also equal to minus 1 by 2. So now what we do? We'll substitute all these things in our this equation, and T is equal to this much. So what we get? Lastly we get that, as you have seen, that T is equal to K times. Now as I can see from here on top, L was equal to power A, M was power B, and G was power C. So L to the power A is how much? Minus 1 by 2. ठीक है. L is equal to as you can see here, है ना, see from here that 2c is equal to -1. Oh sorry, one mistake has been committed here. Time should not be -1, and that's what I was checking for you, है ना. It should be +1. So time is +1 as you can see here, and this is equal to this will be changing everywhere. So this is not like this. This is not like this. L is equal to plus 1/2, since A is plus 1/2, and B is equal to 0, and C is equal to -1/2. So what we get is T is equal to K times under root. Here we were having mass, here we were having G, M, and here lastly it was G, L, M, G. So what you got is under root L upon G. So this is the required relation. As you can always see that T is equal to 2 pi under root L by G. This 2 pi is a constant which we have with us, you know, always we are having with us. ठीक है. So this is there, dear students.